Imagine you've got a super smart robot that talks like everyone else. What if you wanted to teach it to say poggers every time? Normally, you'd have to rebuild the whole robot, every wire, every circuit, just to add one word. That's like fine-tuning a language model. You change millions of numbers to teach it one new word. But what if there was a smarter way? Let's zoom in on how a language model actually works. It reads your words and turns them into numbers, like a secret code. For example, the word cat might become 0.2, 0.8, 0.1. These numbers are called embeddings. The model uses them to guess what word comes next. To teach it a new word like poggers, you'd normally have to change every single embedding in the model. That's 7 billion numbers for a small model, like rewriting every page in a 7 billion page book. Here's where LoRa comes in. Instead of rewriting the whole book, LoRa adds a tiny sticker on top. The sticker doesn't change the whole book, just the part about poggers. So if cat is 0.2, 0.8, 0.1, LoRa adds a tiny rule. Whenever the model sees poggers, nudge the numbers by 0.1, minus 0.05, 0.03. That's it. Only 3 numbers change, not 7 billion. LoRa stands for low-rank adaptation. Low rank means the sticker is super small, like a tiny recipe card instead of a whole cookbook. The sticker only carries the numbers it needs to change, not the whole model. For a 7 billion parameter model, the sticker might only have 100,000 numbers. That's like changing one page in a 7 billion page book. Let's make it real with math. Suppose our model has just 3 numbers to decide if a sentence is happy or sad. Happy sad face 0.9, 0.2. Sad sad face 0.1, 0.8. Normally, to teach it pizza means happy, you change all 3 numbers. But with LoRa, you only add a tiny adapter, 0.3 minus 0.1. So pizza becomes happy sad face 1.2, 0.1. The rest of the model stays the same. Think of the language model as a chef that knows 100 recipes. If you wanted to learn a new recipe, say, pineapple pizza, you don't rebuild the whole kitchen. You just give the chef a tiny recipe card that says, when someone says pineapple pizza, add pineapple. That's LoRa, a tiny card that teaches the model new tricks without changing the whole kitchen. Here's the magic. The adapter doesn't change the model's core knowledge. It only adds a style overlay. So if the model knows Paris is the capital of France, it'll still know that, but now it might say it in your favorite slang. The facts stay the same, the style changes. Let's do the math again, but smaller. Suppose our model has 4 numbers to decide if a sentence is cat or dog. Cat sad face 2, 1, dog sad face 4, 2. To predict cat, the model does 2 times 2 plus 1 times 1 is equal to 5. With LoRa, we add a tiny adapter 0.5 minus 0.3. Now cat becomes 2.5, 0.7. So 2.5 times 2 plus 0.7 times 1 is equal to 5.7. The model now leans slightly more toward cat. Now, let's see how this works in code. Here's a tiny Python snippet. We start with a big model, then add a LoRa adapter on top. The adapter is just a small layer that sits between the model and the output. When the model runs, it first does its normal thing. Then the adapter tweaks the numbers, like adding 0.5 minus 0.3 to the cat rule. That's all the code does. The adapter is so small because it only changes 1% of the model's numbers, and those changes are tiny. For a 7 billion parameter model, that's 70 million numbers changed by just 0.01 each. It's like nudging a giant boulder with a feather. Let's compare costs. A full fine-tune changes all 7 billion numbers. That might cost $1,000 and take 10 hours. LoRa changes only 70 million numbers, and each change is tiny. So it costs $5 and takes 10 minutes. That's not just cheaper. It's a whole different game. But wait, there's a catch. LoRa is like a sticker. It can teach the model new words or slang, but it can't teach it brand new facts. If the model doesn't know what pizza is at all, LoRa can't make it up. It can only teach it to use pizza in a way that fits with what it already knows. Think of it like teaching a kid the word pizza, but only if they already know what food is. Here's another way to see it. Suppose the model knows hello means hola in Spanish. With LoRa, you can teach it to say hey there instead when the user is friendly. The adapter adds a tiny rule. If the user's tone is friendly, translate hello to hey there. The rest of the translations stay the same. That's style, not facts. LoRa also needs clean data. If you feed it messy examples, like pizza is yummy or is it not, the adapter will get confused and add noise instead of learning your style. It's like teaching a kid. If you give them mixed up instructions, they won't learn clearly. So keep your training data simple and clean. Let's do a tiny training loop example. Suppose we want the model to say poggers more often. We give it 10 examples. This is poggers for sure, etc. The adapter learns to tweak the model's outputs, so it starts using poggers 3 times more often. The math behind it: the adapter adds 0.4 minus 0.2 to the poggers embedding. That's all. The adapter is so small, you can run it even on a phone. The big model stays on a server, but the tiny adapter lives on your device. When you chat, the server sends the big model's answer, and your phone's adapter tweaks it just a little to match your style. That's fast, private, and runs on a device smaller than a deck of cards. Let's compare sizes. A full model takes up 16 gigabytes on your hard drive. The adapter? Just 2 megabytes. That's like a single photo. You can store dozens of adapters on a thumb drive. That's why LoRa is perfect for customizing AI on your own computer or even your phone. Here's the full picture. LoRa changes only 1% of the model's numbers, and those changes are tiny. For a 7 billion parameter model, that's 70 million numbers changed by just 0.01 each. It costs $5 and takes 10 minutes. The adapter is 70,000 times smaller than the full model. That's like comparing a grain of sand to a beach ball. So now you know the magic trick. LoRa is like a tiny sticker that teaches the language model your style without needing a fridge-sized computer. You can add new words, slang, emojis, or even your favorite way of explaining math, all with a few dollars and minutes. And the adapter is so small, it fits on your phone. Of course, LoRa has limits. It can't teach the model brand new facts. It can't change the model's core logic. And it needs clean data, no messy examples allowed. But for adding your style, slang, or favorite words, it's perfect. Think of it like a font changer. You can change the font of a document, but you can't add new paragraphs. Ready to try it yourself? Hit subscribe so you don't miss the next guide, where we'll walk through building your own LoRa adapter step by step. No fridge-sized computers required. You'll see the code, the math, and the magic.